Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0843, which indicates a high circuit issue concerning the transmission fluid pressure sensor, or switch A, in the Honda Fit from 2015 to 2020. The diagnostic trouble code, DTC P0843, is specifically related to the continuously variable transmission, CVT system. It signifies an electrical circuit problem rather than a mechanical one, meaning the fault is located within the wiring, connectors, or the sensor itself, rather than the transmission's mechanical components. As we move through this guide, we will discuss the affected components, their roles in vehicle operation, potential causes of this error, and symptoms you might experience. This P0843 code can impact the performance of the transmission, leading to issues that can affect the overall driving experience. Hence the need for thorough troubleshooting. Let's dive deeper into the components involved. The diagnostic trouble code P0843 pertains to the transmission fluid pressure sensor, often referred to as the TFP sensor. This component plays a crucial role in monitoring the transmission fluid pressure, which is essential for the optimal operation of the continuously variable transmission system. Located near the CVT assembly, it helps ensure that the transmission operates effectively by providing real-time pressure readings. If the fluid pressure is too high, it indicates a potential fault that could adversely affect the transmission. This sensor works closely with the Powertrain Control Module, or PCM, which interprets its readings and influences various transmission functions. Addressing this DTC requires a detailed understanding of both the sensor and its electrical circuit connections to the PCM. The primary cause of DTC P0843 is an electrical circuit problem related directly to the transmission fluid pressure sensor. This could stem from faulty connections that may occur over time due to corrosion or wear and tear. It can also originate from wiring faults, like frayed or broken wires, which might disrupt signal transmission to the PCM. The DTC is unlikely to be a result of mechanical issues within the transmission itself. According to the diagnostic information, if the freeze frame data was recorded, it is advisable to check for intermittent failures that might point to specific conditions under which the error occurs. Understanding these potential causes is essential for effective diagnosis and repair. When DTC P0843 is present, several symptoms may become evident during vehicle operation. One of the most common indicators is a warning light on the dashboard, alerting the driver to a transmission-related issue. Additionally, the vehicle may experience erratic shifting or difficulty engaging gears, which can severely impact driving performance. In some cases, the transmission may even go into a fail-safe mode, limiting its functionality to prevent further damage. If left unaddressed, these symptoms can lead to more significant transmission problems, ultimately affecting vehicle safety and drivability. Therefore, recognizing these symptoms early can aid in timely diagnosis and repair. The first troubleshooting step for DTC P0843 involves verifying the problem using the Honda Diagnostic System, commonly referred to as HDS. Start by turning the vehicle to the on mode, but do not start the engine. Once in this mode, clear the DTC using HDS, which resets the system and allows you to monitor new data without interference. Observing the parameters on HDS, particularly the driven pulley pressure sensor voltage, is critical. You are looking for values greater than 4.84 volts. If the current conditions meet this threshold, the failure is confirmed and you can proceed to step 2. If not, this could indicate an intermittent failure, prompting you to check for possible poor connections or loose terminals between the CVT-driven pulley pressure sensor and the PCM. reviewing freeze data can provide additional context if available. In the second step of troubleshooting DTC P0843, you will be focusing on the CVT-driven pulley pressure sensor to determine the failure area. Begin by turning the vehicle to the off or lock mode. This is crucial for safety when you are disconnecting electrical components. Next, disconnect the CVT-driven pulley pressure sensor 3P connector. Following that, you must jump terminals A and B using a wire, allowing you to simulate a test state. For this sensor, Terminal A refers to number 1 of the 3P connector, and Terminal B refers to number 2. After establishing the jumper connection, return to on mode and check the parameters again with the HDS. If the driven pulley pressure sensor reading exceeds 4.84 volts, it confirms the success of the jump, prompting you to proceed to step 3. If the voltage is still below this threshold, you will need to replace the CVT-driven pulley pressure sensor. For step 3 in the troubleshooting process of DTC P0843, focus on checking the continuity of the PDN line. Begin by ensuring the vehicle is in off or lock mode, and then remove the jumper wire you just used. This step is essential to ensure no additional signals are interfering with the test. Jump the SCS line using the HDS to initiate the system check. Disconnect the PCM connector C, noted as 51P next, allowing you to test the continuity between 2 specified test points 1 and 2. These points correspond to the CVT-driven pulley pressure sensor 3P connector number 2 and PCM connector C number 49, respectively. Continuity should be verified while the vehicle remains in off mode, and the test conditions stated in the diagnose manual are followed. If continuity exists, the PDN wire is intact and functioning properly, enabling you to proceed to the next troubleshooting step. Conversely, a lack of continuity will indicate an open in the PDN wire, necessitating repairs. Step 4 involves checking the SG2 line for continuity, which is critical for confirming that the signal wire is intact. Again, ensure that the vehicle is in off mode and maintain that both the CVT-driven pulley pressure sensor 3P connector and PCM connector C are disconnected. The continuity test will focus on 2 specific points. Test point 1 involves the CVT-driven pulley pressure sensor 3P connector number 1, while test point 2 is PCM connector C number 1. If continuity is present between these 2 testing points, the SG2 wire is confirmed functional, allowing you to consider updating the PCM software if it's outdated. Alternatively, substituting with a known good PCM may also resolve the issue. If upon substitution or update the DTC P0843 disappears, either complete the procedure or replace the original PCM. However, if continuity is absent, you must repair the open circuit within the SG2 wire connecting the CVT-driven pulley pressure sensor and the PCM. After performing all necessary troubleshooting and repairs related to DTC P0843, it's essential to conduct a final verification of the repair. Start this step by taking the vehicle for a test drive under various driving conditions to ensure that the transmission operates smoothly without any hesitation or error messages. It is vital to monitor the performance closely during this test. The transmission warning light should remain off, and the vehicle should shift normally. Post-testing, check the HDS once again to confirm that DTC P0843 does not reappear. This not only ensures that the issue has been resolved, but also confirms the reliability of the repair performed. Finally, documenting the results and any changes in the vehicle's performance can guide future troubleshooting steps if similar issues arise. To prevent future occurrences of DTC P0843, implementing preventive maintenance practices can be highly beneficial. Begin with regular inspections of the transmission system, paying special attention to the wiring and connectors associated with the transmission fluid pressure sensor. Frayed wires or corroded connectors can lead to electrical issues that may trigger error codes. Monitoring the transmission fluid levels is also vital, as low fluid can cause pressure anomalies that might lead to complications. Additionally, ensuring that the vehicle's software is up to date can prevent electrical miscommunication between the sensor and the PCM. By actively maintaining these components, vehicle performance can be optimized and major repairs can be avoided. In conclusion, DTC P0843 concerns an electrical circuit issue related to the transmission fluid pressure sensor in the Honda Fit 2015 to 2020. Understanding the role of this sensor and its relationship with the transmission is vital for effective troubleshooting. The step-by-step approach outlined guides you through verifying the problem, diagnosing potential electrical faults, and ultimately, ensuring that the vehicle operates correctly. A successful resolution involves addressing both the immediate issues and applying preventive maintenance to avoid future occurrences. By remaining vigilant and proactive, you can ensure that your Honda Fit maintains optimal performance and reliability on the road. Please like and subscribe to the channel. See you next time.